I'm a disembodied head. I'm just floating. Where's my limbs? Where's my limbs? Where's my limbs? I've got hands. I've got hands. Yeah, hands. Hi. Thanks for having me. This talk tonight is going to be about CVE hunting-ish. When I originally conceived this, I thought we were going to be spending about 4 hours doing a real hackathon here where we were going to try and set you on a task and find loads of vulnerabilities for us to go and report, etc. As it turned out, we've got an hour. So what you've wound up getting is a thing where you can sit back, relax, and enjoy, and just listen to the sound of my voice. There's nothing really practical, but at the back end of this, if you're watching the video, there's a bunch of commands that will help you set up and target WordPress and their plugin ecosystem, basically. So there's something to be playing along for, and if I'm coming back later, if you'll have me back, we'll do a workshop where hopefully you guys are in charge and you're going to be looking for vulnerabilities using the techniques here. So this might be part 1 of 2. So thanks for having me. I've got to click in here and I'll click next. So who am I? Who am we? I'm a human that likes to help. My online handle is Corner Pirate. There are reasons for that. They're not that great. My name is Paul Ritchie. I'm the managing consultant running the team based in Scotland for Pentest Limited. I've been a penetration tester for over 15 years at this point. I'm a parent, I'm a guitarist, I love sci-fi, and I'm a general optimist, meaning I like to see the positives in the world and in people and things. So, you know, it's a much happier outlook I strive for. Pentest Limited, we were founded back in 2001. We've been on the scene there for a very long time. We specialise in, you guessed it, penetration testing. Classic things there: application testing, red teaming, infrastructure. We've been doing those for forever. Newish service lines, estate discovery. How can you secure your network if you don't know what assets you've got? That's what estate discovery is going to help with. Agile security. It just means that we're going to engage in a more agile manner. There's not a big cycle of scope, test, report. It's breaking those things down so that a pen tester can be deployed into a more agile environment at shorter notice, and they're able to deliver things that are more akin to the way that modern development practices are following. So we might not deliver a full report at the end of it. The chances are we're just going to be raising tickets and then joining your morning meetings for basically becoming a part of your team effectively. So that service line there is up for an award. You can find us talking about that on Twitter, etc. And if you don't mind voting for it, that'd be great. I think that's the marketing part of the job done. Let's fire into the actual thing. So, an actual hackathon. I love developers. I'm a failed developer, I always say, as essentially I spent 5 years at university learning how to code. I got an MSc in software engineering, basically. But I couldn't find a job at that point. The dot-com bubble had sort of burst, so I couldn't really get a job. It was impossible to get a graduate job that year. But what I'm going to say is I love developers, but hacking a hackathon in the sense that they use it, where they actually write code, they create something beautiful and wonderful. That's not hacking for me. That's much more sacred. You're actually making something. When we say hackathon, we mean we're actually trying to break stuff, right? Hack for me means getting an axe out and knocking something up. So when we say hackathon at Pentest, that's what we mean. Pre-COVID, we'd meet up twice a year and we do internal talks. There on the left-hand side is the gorgeous, the uncomparable Sam Thomas. He's our director of research. He's a wonderful soul. More on him being gorgeous later. On the right there, that's Lorenzo. So these hackathons have 2 parts. There's the internal talks at the start, where Sam will set a direction for the hackathon and be visionary and wonderful. And then any interesting projects or tools that we've developed in-house are going to be presented as well. So that's what's happening on the right. After that, we move on to CVE hunting. So there's a whole bunch of us in our small office up in Manchester, and there's me on the right, being picked out. That's the least flattering photo of me in history. My friend shared that all over Twitter. And I now jog and avoid cake, and it's working so well that I've lost rather a lot of weight because I'm just a little head. So it's all good. But why do we do these hackathons? Just for the love of seeing each other, because we're all remote based. We've been remote based for a really long time. COVID has shown other organizations why we need to do these. These are basically isolation busters. You meet up twice a year, you really get the value out of it. You catch up with people in their lives. And then we do B. We go after vulnerabilities. So several of the vulnerabilities on the list would have come out of hackathon, or at least the energy that the hackathon has generated, because you'll talk about interesting targets and you'll do whatever. I've highlighted that CVE there, 2020-8498. I might have been doing this for 15 years, but the only CVE I have to my name is that one right now. So I'm a bit of a fraud to be here talking to you about them. I don't feel like I'm a serious researcher if I've only got one. But hey, 2020 was the year that I said I am going to get a CVE, and I had one before January was out. So maybe I'll give myself a pass there. So we'll be talking about that one later, so that you know more about the discovery process, and I'm going to set the how I found that so that you can use those skills too. So the basics: CVE for the uninitiated. CVE stands for Common Vulnerabilities and Exposures. This is what MITRE.org, the people who manage them, say. CVE is a dictionary that provides definitions for publicly disclosed cybersecurity vulnerabilities and exposure. The goal, blah, 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 blah. It's quite wordy. So I've tried to summarize that a little bit. Too long, didn't read. What you actually need to know about CVEs from my perspective. CVE, Common Vulnerabilities and Exposures, CVE. We need to remember what those are, because one of the things that you might be doing in your career is going after certifications, and I can guarantee you there's points and gold in them dar hills if you can just memorize some TLAs. That's a 3-letter acronym, if you're wondering. If you can memorize those TLAs, you're going to be 15, 16 points into your multiple choice exam for free. So yeah, go for it. CVE, Common Vulnerabilities and Exposures. For me, it is a database of known vulnerabilities. Lots of tools integrate with it, and they're a kind of standard format. Each vulnerability has a unique identifier, a CVE ID. It's in the format of the string CVE, then hyphen, the year, and then a sequence number of digits. So the minimum value for 2020 is CVE 2020-0004, because it starts off with three prepended zeros. That's the minimum one you can get. Maximum one's all those nines. It's just a sequential ID. It starts at 0001 for the first one reported in 2020, and then goes up. The year is not the year of discovery, but it is the year that the vulnerability is made public. So you could find something now that you don't get publicly disclosed until 2021. It'll be CVE 2021. So there you go. What is ethical disclosure in a nutshell? And I do actually love quite how much a nutshell looks like a human brain. Now that I've seen one up close and dissected, not a human brain, but the nutshell. So what is ethical disclosure? The process of passing security recommendations to a vendor. This is done in secret so that they can mitigate the risks before they are exploited by malicious threat actors. I wrote that. I'd obviously say that's wonderful. That's got to be a great definition, possibly beautiful. Best definition in the world. Here's ours. So there are various ethical disclosure policies, and we have one so that when we're disclosing to a vendor or a vulnerable project, we can link them to it and say, this is our process, you're agreeing to our terms. Suck it or see. That's it. 1.1, very first paragraph. The purpose of this responsible disclosure policy is to ensure any vulnerabilities discovered by Pentest Limited are responsibly disclosed. Strong opening. Baller. 1.2, wherever possible, Pentest will follow the coordinated vulnerability disclosure process outlined in CERT's Guide to Coordinated Vulnerability Disclosure. So coordinated vulnerability disclosure, that means really that we're going to attempt to bring the vendor along with us. We're going to not just unilaterally write a blog if we can avoid it. We want the vendor to be involved. We want the vendor to be in the process. We want them to make a patch, and any other vendor or any other organization that is like a major risk factor in the vulnerability disclosure needs to be aware, so they have plenty of time to fix their stuff before research is released. The long paragraph here, the real meat of the policy, is in 5.3. Coordinated public disclosure. The aim of CPD is to not disclose sufficient technical details to aid any other party in reproducing the issue prior to the technical solution being available. So we could be around saying, I've got this leak vulnerability in WordPress today, yeah, it's a SQL injection, but that's too vague for you to be able to specifically go and find it yourself. If we got more specific, said in xyz.php, that would be enough detail for someone to go and do it, so we can't talk about things like that. If every reasonable effort has been made to contact a vendor, both directly and through any relevant third parties, and it has not been possible to open a line of communication, it may be necessary to disclose the details in the interests of end-user security. So ultimately, we're doing this for a reason. We're trying to secure things that are used by people, protect people's data. It's not like we're just doing this for the fun of it. We are trying to secure products, and the research is done pro bono. It's free. So it's just our time that we're giving up to secure these products. So ultimately, we're going to want to put the information out into the public and also help secure things. So that's why we have that one. So if there is no engagement from the vendor, we may choose to publish it. Pentest would choose to do that 45 days from the initial attempt to disclose the vulnerability. And if we started with a vendor, the vendor gives up on us, or we haven't been able to contact them 45 days after we started the process, Pentest may consider unilateral disclosure, and I'm kind of at that point right now personally with my most recent bit of research. Steps of ethical disclosure. So that's a policy, but really what are the steps that you are going to have to follow if you're going to try and do it? Number one, choose a target, pick something, stay safe, stay legal, never hack anything that you're not legally allowed to do so. That would be stupid. You don't want to risk your liberty. Only an idiot would do that. Don't do it. Find a vulnerability. Use your elite skills, because you've definitely got them, to find anything which could be improved. Number 3, identify a point of contact. If there's a vendor, check the website. If it's open source, try and find the developers on GitHub, Twitter, LinkedIn, things like that. Deliver details to them. Securely transmit the details to them. Await a patch. Just chill out. Put your feet up. You just have to wait until they produce it. Assess the patch is secure. Assuming a patch comes back, assess that it's secure. Once that's all done and it's ready to go, request a CVE, because that's kind of game over. When you're getting that far, the public details are going to be in the CVE database. And then once you've got your CVE, you can then tell everyone, and you can get that news out to the InfoSec community, and the InfoSec community will love it, because we all love a new vuln and a new exploit. And then you just secured the internet. The legend that is Sam Thomas, remember, Director of Research at Pentest Limited, introduced me to the party parrot, and he drops it every time he finds a 0 day and something, and I've fallen in love with this little guy. So securing the internet is what it's all about, and it's a vital part of the process. You have to dance like the party parrot. Ethical disclosure realities. So if I showed you the generic process, this is a little bit of a high level summary about the realities of this. And there's a couple of anecdotes coming up in a minute which fleshes these out. Choose a target. Nobody can stop you, but remember, stay legal. Only idiots only bad people let friends attack illegal things, right? 2, find a vulnerability. Nobody can stop you. They can't stop you. You can absolutely find a vulnerability. Identify point of contact. Sometimes this is easy, sometimes this is impossible, and we'll sort of see why in the anecdote in a minute. Deliver details to them. How do you do that securely? That's a challenge. You probably don't want to just send an email with the details unencrypted, because then it's gone over the internet, God knows how. It's arrived, sat at rest insecurely on their mail server, on the guy's computer, on the person's mobile phone perhaps. So what you want to do is, essentially, the first stage is, once you've identified a point of contact, is I kind of got a vulnerability. I'd like to maybe disclose it to you. And I don't know why my hands are like a little ocean, but they are. So we'll just keep going with it. Don't worry about it. So then you send them the email, and then you got to be like, but I'm not going to tell you the details now. Have you got a PGP key? Have you got any other way of disclosing it? And then you got to negotiate really how to securely deliver it. So it's a negotiation piece. I wouldn't straight do it. If the people have a bug bounty, they're going to drive you towards the bug bounty. If the people have an ethical disclosure policy, chances are they have a PGP key. They're going to chuck one at you, and then you can encrypt the email. Sometimes it's encrypt to zip with a secure password. Ask them for an SMS, mobile number, so you can SMS the password to them. It's a negotiation. Then you have to await a patch. This could be minutes. Again, the sainted Samuel Thomas had the benefit of dropping a vulnerability, a really significant one, in I think Joomla, and his timing was impeccable because they're like, mate, thanks for this. We're about to make a new release tomorrow, and they patched it, and it was out there on the update servers by the morning. So it can be like a really quick turnaround, or it could be months. So the worst one I had in my experience was I disclosed a vulnerability in a major US-based IT vendor, and I chucked it in there, and I didn't get a reply from their own security team saying, we acknowledge the receipt of this. There was not a reply at all. And then 2 whole years later, I got a 1-word email back from them that just said, thanks. And then I replied back to them going, did you fix it? Because thanks is a bit too vague. I never saw a CVE for it, never had any more contact with them, have no idea if it was ever fixed. And 2 years on, I'll be honest, I'd wiped my laptop and I could not remember what I told them the vulnerability was. Anyway, you got to assess that the patch is secure. Most patches do solve the problem. Now, not all of them do. Sometimes you patch something and you've actually not quite done it right, and you've left the vulnerability there. So we have to check that there's not a patch bypass. If the vendor has literally just gone patched, and then they sent out an update, and you find a bypass of the patch, you could technically game and mine another CVE vulnerability entry, because you could be like, well, I found it and I reported it to them, and then I bypassed their patch. So they're in different versions of the software, if you see what I mean, because they'd be in version 1.01 would be initial vuln, and then they patched it at 1.02, but the patch was inadequate, incomplete. So now you've got 2 CVEs effectively. So assess the patch is secure, really, and then request the CVE. How do you do that? Who from? Sometimes vendors can dispute them. So I think the buck stops with MITRE.org, who manage the CVE database, but big software vendors who get an awful lot of disclosed vulnerabilities, a lot of them are essentially able to generate their own CVEs IDs. MITRE has trusted them. So they'll triage the vulnerability for you, generate a CVE, and then give it to you as a researcher. So I think Sam had that experience with Joomla. I think they're one, but the vulnerability that I found, I didn't really have a vendor of any real scale. So effectively, I have to go to mitre.org. But the way to find that information is to go to their website, and you can access how you're going to request based on the vendor. So a couple of horror stories here. Where do I start? Nightmare, the school lawyers, right? Remember I said twice already, only pick things that are legal. I say that because I was a stupid corner pirate back when I started my career. Circa 2005, there weren't really any bug bounties. CTS weren't a big thing. Nobody even knew what a penetration test was. So it was common for some hackers to just have a punt at big companies in the evenings or weekends, and then they would just straight up tell them vulnerabilities, and they had no permission at all to do it. This was totally the Wild West, and I do not encourage it today when you have bug bounties, much more open source software than 15 years ago. So you've got plenty of legal targets to be playing with. No one can stop you looking at an open source project. So the other part of that is, some of the time you would get a thank you. Like when I disclosed 2 vulnerabilities to Microsoft were actually kind of ahead of the curve in this regard. My name appears twice on their archive, 2008, 2009. This is before I gave up disclosing things, really. No CVEs came from those though, because they were web application vulnerabilities in their public websites. So they weren't like, it wasn't like I was owning Windows XP or Windows Server or something like that, or Excel. It was literally their web presence. So I had an SQL injection on one of their sites that let me dump, I think it could have let me dump a few million data records, and I think a cross-site scripting on MSDN, the sort of their help page website. So effectively, Microsoft were kind of good. They didn't get the lawyers involved, and they actually said thank you and invited me to their parties in Vegas for DEF CON and Black Hat, and I'm like, I'd melt in the desert, sir. I'm not going. But thanks for the invite. They kept inviting me for about 6 years. Anyway, nightmare number 1. More often than not, this meant that you didn't get a positive response because you hadn't actually had authorization to test it. So you were told to stop doing what you were doing. You get a cease and desist letter, legal threat, and you were literally trying to help. You were trying to help them secure their product and help their users have a better level of security, and you would get a cease and desist letter. And this still happens today. It is in a much better place than it was back when I was doing this more regularly. Now I would not even think about going after a target that wasn't completely legal to do so. I was just young and stupid. So eventually I stopped looking because I was just tired of it. There's no point in getting in doing free research work, trying to hand it over ethically, and then getting sweaty palms between emailing the contact, waiting for the reply. It just wasn't worth it for me, because the for every Microsoft saying thanks, you'd get about 5 with a lawyer's letter, and it was just not worth it, right? So we'll move on to no contacts. So it seems like the easiest thing in the world, right? You found a vulnerability, you just need to tell someone about it and to tell them about it securely. But this is actually quite a fraught part of the disclosure process. I have emailed contact@domain.com, so you just try and find their main contact us form, or I've tried emailing the sales lines. Sometimes, ultimately, I've used DMs or Twitter. So I did one for Virgin credit cards, where the only reasonable way I could talk to them at the time was via their marketing account on Twitter, and it was like several layers to get to them. That's not ideal. So if you're in an organization today and you are empowered to do so, create a page on your contact us page which says, if you've identified a cybersecurity issue, please contact this email address, and here is a PGP key. That is a relatively cheap way of getting people from the community to be able to disclose vulnerabilities. There's no bug bounty there. There's no promise that you're going to pay them for it. So it'll be a low number of emails, I'm assuming, but it will help your organization. You'll be getting information for free. Because while the bad guys are looking at everything anyway, the good guys do too, and will occasionally tell you about it. So anyway, when you contact these people whose job it isn't really to do it, you get, "It's not my job, mate," and it falls on deaf ears. But what if you exhaust your ability to find a contact? So I'm kind of there now. I'm living this nightmare right now. You've got 2 choices. You either give up or you go full disclosure. So if you give up, you just simply know about the vulnerability and you don't tell anyone, and you never abuse it, right? No problem. You've not done anything illegal. Just don't tell anyone so they can't use it. Your conscience is clear. You tried your best. Or you can go full disclosure. A total YOLO move. You only live once, guys. Send it to full disclosure, blog about it, or otherwise publish the details. There's a major ethical controversy right here, because there are some people in the community that are like, doesn't matter, shouldn't even try and contact the vendor. You should just put it on full disclosure and let it go. They'll find it that way, and they'll be forced to fix it. Other people are totally against it. You should never do it if there's any way where the research that you're putting out could affect end users, right? Because there's an ethical dilemma. So I'm living this nightmare right now. After our hackathon, when COVID hit, we had one remote hackathon this year. So the first one was in January, and then we had another one a few months later remotely. So one of my team essentially picked an education product, and we found a bunch of vulns, and then I stepped in a week later, because sometimes it's not the vulns found in the 4 hours, 6 hours, 8 hours of hackathon. Sometimes it's about the energy that you get from the hackathon bleeding into the spare time coming in the next couple of weeks, where we find the actual vulns. So I stepped in and found an RCE, a remote code execution vulnerability, and that's well beyond our 45-day disclosure policy statement. And I've tried to contact the vendor, but there's a bit of a splintering problem here, because there's no point. It's just teasing you guys talking about it. But what I'm saying, I'm living in this nightmare right now. So we are there on the knife edge of deciding, do you put it out there when it can affect users, or do you not? And I think we're coming down on the disclosure route, because we've really exhausted trying to talk to them, and yeah, I'd really rather not. It's not a good look. But anyway, what about my CVE? Let's focus on the one we can talk about today, and the skills used to find this one, or at least the environment that you need to set up to be able to go and target a WordPress plugin. I'm going to talk about that at the back end. So if you're looking for that, you can skip towards the end of the video, and it'll all be relevant to how you set up an environment. So I've got my CVE. The ID is 2020-8498. Its risk score, CVSS, is a common risk analysis calculation. Stands for Common Vulnerability Scoring System, CVSS. It runs from 0 to 10.0. It gives you a number between 0 and 10, really. And that mad string here on the right means various things like access vectors over the network, the complexity is low, privileges required are low, but you do require privileges. The affected item is the GistPress WordPress plugin, and I really love this. How well maintained the CVE vulnerability database is with these details, because you can tell I am a verbose person. I cannot hide that fact. I overwrite, I overspeak. So it's really nice that I've managed that the CVE database is so brief, because this packs a lot of information. XSS, cross-site scripting, exists in the shortcode functionality of the GistPress plugin before version 3.02 for WordPress via the includes/class-gistpress.php ID parameter. This allows an attacker with the WordPress contributor role to execute arbitrary JavaScript code with the privilege of other users, e.g. those that have the publish post capability. Right? So I didn't write that. I wrote something much longer, and they went and shortened it for me. So that's wonderful. But let's expand on this so that we have enough information. XSS, for the uninitiated, I'm assuming most of you do know about this, but cross-site scripting is an input validation, and I would argue an output encoding vulnerability. So the risk that comes from poor input validation, not checking what user information is coming in, and it only works where that is then used without encoding it properly. So it's a bit of both, but usually it's categorized as input validation weakness. It exists where user controllable data is handled insecurely, right? So anywhere that data is handled insecurely and it's echoed back into an HTML page, you have a problem. There are 3 common types. There are reflected, where the payload is in an HTTP request, and then the payload is executed in the HTTP response that comes immediately from it. So the payload's in the URL, for example, and then the response page that comes back. We'll show a little example of that in a second. Persistent is where the payload is put into the database via one method. It could be an HTTP request, and then some other HTTP request later will request it, and then in the response page it will get it from the database and it will pop up. Or there's DOM based, where the payload is added into the document object model. Let's try that again. Where the payload is added into the document object model without the HTTP request being made effectively. So if you've got a URL and it's got a hashtag at the end of it, hashbang, and then there's something after it, that's like a URL fragment, the bit that's after a hashtag, then if the request is going to the server, the browser won't send that part, but maybe the HTML page will get that hashbang value, and then it'll inject it into the DOM. Then you have a problem. So that's us for the 3 common types. But what are the impacts? It allows an attacker to inject arbitrary HTML tags or JavaScript commands. But okay, seriously, what bad stuff does it allow? It's a bit cold hard to just say HTML tags or JavaScript commands, but what does it actually do? Session writing mainly. So the most common kind of attack is, if you can do this, you're going to be able to execute commands within the privileges of some other user session. That means it's privilege escalation. So that's the issue with my instance of XSS in GistPress. The thing is that you get privilege escalation in this because you've got a lower privilege user, the contributor, who's able to take control of an admin user, or at least someone that's got the ability to publish posts, for example. Alternative stuff, very robust research exists for XSS, so you can pretty much achieve a lot of things with it. Port scanning and service interaction from the victim's web browser to internal applications. So you could literally take control of the victim's web browser and have it surreptitiously send requests to internal hosts behind the firewall, which you wouldn't otherwise be able to see. So that's lateral movement. especially if the victim might be authenticated via like a single sign-on. You might be able to reach domains and access all the extra apps that they have the ability to see. So XSS can, in the right hands and circumstances, be completely lethal. So there you go. Let's have a little signature of a reflected XSS. Like I said, this is where the payload is embedded in the HTTP request. So in this case, it's a get parameter called MSG, and then it's returned in the HTML source without having any input validation or any output encoding. So in this case, it's just going to take the value of MSG and echo it straight into the page. So here we go. So what do we do with that? Excuse me, just going to cough. So Payloads 101, script alert 1. It's a classic trigger. This is how you often prove that XSS exists. It is not an active payload. It's not malicious in any way, and unfortunately over the years many developers have seen the disclosure with a script alert, and their solution is just block the string script alert 1, and that's not sufficient defense. Like, really, that's just us trying to give you something that's safe enough for you to replicate with. Slightly more malicious one is this one here, where you inject a command to create a new image in the HTML page, and then you set the source for it to be a IP address or a host name that the attacker is under control, and then you put the cookie value here onto the end of it. So this is what an HTTP server looks like if you start it simply with Python, and here is the GET request that's issued to our server when the person opens this a web page where you've now embedded this. So that would send the cookie value over to the attacker. So all you need to know about JustPress before we get into the other stuff that's more interesting, let's just be formal about this. We need to know about our target. So WordPress is a content management system, CMS. It's often used to power blogs, simple WW websites, but it has a rich plugin ecosystem that can extend functionality to add in product ranges, shopping carts, everything. It can do e-commerce websites. Gist is a simple way to share small code snippets, and it is made by GitHub. So if you've seen GitHub, it's great for lots of things. If you're going to have a big project and you want lots of people to collaborate on it, GitHub is a great way to go. When you just have, say, a simple single file script that you want to share, Gist is actually fair enough. So it's to scratch that itch, so you don't have to make a whole full-blown repository. You just give it a single file, and away you go. When a shortcode is added into WordPress content, the CMS will replace that code with something else. For example, this will be replaced by a video player showing you a preview of YouTube, and that's like the square brackets, and then it says YouTube space and then the URL, right? So that's a shortcode because you're just basically doing it that way. The word YouTube is an identifier so that the WordPress knows which shortcode handler it's going to send it off to, and then the data that it's looking for is over there. You can actually visit that URL. I'm not the kind of person to just straight up rickroll you. That's been done. Nope. That is a Doctor Who relevant thing if you're interested. JustPress is a WordPress plugin which handles shortcodes for content stored on Gist. So I've established what that is, and then tied it all together for you. So that's what the target was. Abuse. So how can I abuse it? I would go to just.github.com. I'd create a new file called anything.json with the contents like the example as shown below, and I'd save it. So the interesting thing about this is that it just has some HTML inside a valid JSON sort of encoded format. Note that the file name must end in .json because JustPress automatically appends .json before requesting the file, so we'll see that in code in a second. Having saved the file, it would be accessible at a URL like the one shown below. This one's now gone. I've deleted it. As a WordPress user with contribute privileges, create a post with a shortcode like this: gist space ID equals and then some ID value. So that's how the shortcode is formatted for JustPress. They just want the word gist to identify, so that WordPress can identify which shortcode handler it's giving it to, and then here's how it wants its input. It wants ID equals that. Payload execution. Anyone previewing or interacting with the post would be exploited. So anyone that previews it would get the pop-up. So in most WordPress systems, it's quite common for there to be contributors, and they could be freelancers that are there to write articles for a website. They'll have contributor rules, but then the people that actually own the website don't want them to be able to publish content directly because malicious things could happen. So, and they certainly want to make sure that the quality articles are going out. So they want to have like a review ability. So you give the contractors contributor rules, and then you make sure that someone else has the ability to then post it. So this would be an exploit that would work, because after the contributor has put this thing in, someone has to come along in a legitimate workflow to actually review it before they can post it live. So the second that they go to review it, they've been exploited and it's game over. So that's how the privilege escalation would work, and that's how it would get its privileges up in this case, because there's no emailing a link to someone. They just have to do it as part of their workflow. You go, hey, the thing is needed to be reviewed now, and you wait for the shell basically. So why did this work? It worked because JustPress wants to load a URL based on the value of the ID part of the shortcode. So it wants to make this URL here from the ID value, and then it appends .json, so that's why your payload on gist has to end in .json for the file name. So it's going to go ahead and load this file here. And this is a file generated by gist.com which describes the content in gist. So this one here, the ID for the for the specific gist is like the username / this number, and it's going to look for this because this file here is legitimate and it is generated by gist.github.com. So the attacker, as it were, even though they've uploaded the file, wouldn't have the ability to influence that content. So it gives a short summary of what is in the gist so that it sort of summarizes the project. So that's why the developer of JustPress literally just trusted the contents of the file and echoes it. Because it does, of course, this file, even legitimately generated, does contain HTML content. It's just the guy's just trusting that gist.github.com is not trying to abuse them. So our XSS worked because we manipulated the URL that JustPress was requesting by manipulating the shortcode ID. So instead of it just being the username and ID, we've put in this extra part here, which is taking it to a file that we were in control of on inside that gist, basically. So now JustPress was asking for this, where it has added the .json back on, and the content that was inside anything.json was under our control, so we could write whatever HTML we wanted, and that's how it worked. So how did I find that? And we should definitely just take a little break here. I'm getting a bit tired.
For you, Mr. Thomas, my love for you is like a most exciting carrot. Your face reminds me of stunning aardvarks. Together we are like pasties and mayonnaise. Oh my darling Sam, my exciting carrot, my stunning cabbage, the perfect companion to my pasty soul. Strawberries are red, cornflowers are blue. I like drinking tequila, but not as much as I love drinking with you. Darling Sam, your thighs are like adorable pens on a winter. That's enough of that.
I'm a little bit sorry about that, but Sam, I love you. So I wanted to let you know that. So how did I find it? Little old me. I had a qualified lead from a certified legend, Sam Thomas, our director of research. So I have previous experience of WordPress as well. I've used that to blog for several years. And I have programmed a little in PHP which helps, and I have some code review skills which helps. So if you're going to go and start finding loads of vulnerabilities, one of Sam's big things is he says go and learn how to code and go and learn how to do code review, because you'll find loads more vulns if you do. So what's the qualified lead? Sam. Oh, glorious Sam. What a handsome man he is. The qualified lead, because he's a man of very few words, he just leaned in and he went, WordPress, shortcodes. And I was like, I don't miss a lead from Sam. I'm taking it. So on the hackathon, I just went and followed these techniques that I'm putting in here. So first off, learn about your prey. Guide to WordPress shortcodes. There's a link there. It appears at the back end of the talk as well, the links. This is a short piece of code, and it's talking about add shortcode registers a new shortcode handler to WordPress. So that YouTube one that we saw before, that's got to be registered at some point, and it'll say add shortcode, and then here it'll say YouTube. And that's a summary of the name of the plugin, basically. This function here declares what happens when the shortcode is called. And this add action function tells WordPress to call that function. So unsurprisingly, the name solcodes _init appears here and here, because that is the function that it's going to call. So then how do you use this guy's example plugin? You go square bracket and inside it current _ year, and wherever current _ year is, you're going to get the year using getDate, which is a PHP function. That's all you need to know. That's all the shortcode is. They are much more complicated looking when they're real plugins, because it's maybe got to go to a third-party API or whatever. The JustPress one had to go and download a URL. But ultimately, those are the free functions. So these are good indicators for you to be able to look to go and hunt for potential targets. So if I'm saying to you, and I'm saying you should go target. You should go take Sam's advice. There's a qualified lead there. WordPress, shortcodes, right? There's vulnerabilities there to be had. So we now have threads to pull on. So how do you go and find potential targets that are both WordPress plugins and use shortcodes? You can use your knowledge of add _ shortcode to go hunting in GitHub. If a lot of them have got their source code in GitHub, and a lot of them do, not all of them, so you're not going to find everything, but it says 678 repositories have add _ shortcode, and there's a good bet that this one here is a specific shortcode related to a bit of code. So that one's to do with code accounting, whatever that is. Number 2, you can try and find threads to pull on by using the WordPress plugin search function. So I've just searched for shortcode and it's returned a bunch of them. The interesting thing about this one is you're going to see the number of active installs and what versions of WordPress can use it, etc. So comparing those two techniques, using GitHub search, this is the one that I used to find JustPress. I literally just searched for add shortcode, browse, found one, bang, looked for a vulnerability. It worked for me on the day. Unfortunately, what's good about that approach is it's straight to the code. I like that very much because I've got those PHP review skills, so you can kind of see the function quite quickly, even just in the summary page of GitHub. So you could go hunting without even clicking at the repository, really. However, the add _ shortcode, I don't think that's going to be a unique function name. I might be wrong there, but it seems like an obvious title for that kind of function. So it might be mixed in with other plugin ecosystems. You have no idea if the plugin is popular or not from the repository, because the repository is just going to have the code. It's not going to tell you how many installs there are, so it's kind of useless. Whereas if you use the WordPress plugin search, you're told how popular the plugin is, which is great. You also know for 100% certain that it's relevant to a WordPress plugin, because the WordPress store is only going to have WordPress plugins. But you're a hop away from the code. So really the answer is somewhere between the two. You might want to look here and then or do both of them, really. Choose your weapon. So now you have a target. What now? Lots of kisses for Sam. Always kiss to Sam. So this particular slide was the one photograph that I have of him. I'm legally not allowed to have other photographs of Sam. But this particular one that I was sent when I went, has anyone got any photographs of the last live hackathon? They gave me this one, and it's really quite fortuitous because he was talking about moving tests from the darkness into light. And what he's saying there is that many pen tests are black box. That means you can't see the contents of the source code. You don't have any additional knowledge of the target. You're literally just testing and you don't know what's going on. So you have to analyze by observing what goes in and what comes out with no real idea how it's transformed inside that box, right? That's what a black box test is. And so one of the things that Sam is tremendous at is converting things that are black box into being at least grey box. He'll find some sort of vulnerability like path disclosure, directory traversal, things like that, or he'll find RCE. That means that you can, if you get remote code execution, you can take complete control of the server. What you'll do is you'll then dump the source code off the server and then look at the source code for more vulnerabilities. So he's excellent at using those kind of techniques. Also, if anything is open source, you can get access to it and you can download, install it locally. I'm pretty sure that some of the best testers that Pentest have hardly ever actually send a request to the customer's target until they've already found a vulnerability in like a local instance of the target, and then they go at it, because that's a more sophisticated way of behaving, and you'll see why, because you can get more debugging information really. So be like Sam. We should all be a bit more Sam by setting yourself up for success. So in this case, we have source code of the plugin because we've picked a relatively easy target to get into. So if this is your first time doing vulnerability research, this is why I've chosen this. It's a good one because it's going to be most likely something that you've just found in GitHub with that search. So it is already a white box definition. So you might be thinking, I've got the source code, Mr. Pirate, Corner Pirate, why are we going to try and do anything else? We've already got the source code. Well, you could still bring a bit more light onto that box and make it even paler. Because number one, you've got to set up your own local WordPress server, and I'll show you how to do that. Then number two, you've got to install the plugin. I'll show you how to do that. Number three, you then have to access the WordPress log files, which you might not know how to do. Number four, making edits to the plugin code to add additional debugging that helps you zero in on a vulnerability. So that's kind of one of the techniques that was really useful when Sam was demonstrating how he'd do this kind of stuff. Is he was going, you just edit the plugin. Just know, if you know enough about the programming language that you're looking at, just add more debugging things, and it makes perfect sense. So by the end of this talk, you'll have your own environment and you'll be familiar with those techniques. Right? Getting Docker. So Docker, how to describe this? I'm relatively late to the Docker game. It's not a virtual machine, it's a container. But the idea is that you have an ecosystem where you can download and run a small containered version of, say, a LAMP stack, Linux, Apache, MySQL database, and PHP is the exact stack that you're going to need if you're going to be playing with WordPress, because that's its stack. So Docker is ideal for this kind of situation because you can run a command or two and you'll have a version of Linux running that you can access, and you'll be able to have WordPress in seconds. However, it does rely on installing Docker first, and here's how you install Docker. These commands on Kali, the links here and the links at the back end. So really this is for the video if you're going to be following along and preparing your environments before we come along and do a bug hunting thing in round 2 of this workshop. Basically, once it's working, you can prove it by docker run hello-world, and it'll tell you hello. So if you get there, your container's running and it's all working for you. Getting Docker Compose in Kali. So this, again, a guide here and the URLs at the back. The too long didn't read. I recommend using Python's pip mode of installation. So there's a sort of install it via GitHub kind of approach. There's an install it via a Linux repository kind of approach. But the one that was easiest for me is use Python's pip, because it's just pip install Docker Compose once you've got Python free. So again, this is how you install this in Kali, and it worked fine for me. Docker Compose magic. So what Docker does is it runs containers. What Docker Compose does is it lets you build containers that are going to be run, and it lets you build a complex container ecosystem. So someone has already prepared, this user on GitHub, Nizhar, has already compiled a WordPress Docker Compose, which is beautiful. It meant I didn't have to make one for you guys to set up. So So what this Docker Compose does is it runs one container for MariaDB, which is MySQL, and it runs another one as the app server, so that the PHP WordPress application can run in there. Because that's how you architect a WordPress install. You shouldn't really stick the database server in the same host as the app server. That has problems. Like it's not going to really scale too well, and it's worse if I get a remote code execution in the app server. I'm guaranteed to get the database, but you almost always are if you get RC on the app server. But like there's reasons for separating it. It gives an attacker something else they have to do. But anyway, you have this Docker compose here gives us this Docker compose.yml file. And when you run the Docker Compose up in that folder, it's going to look for this file, and it's going to download and run both the database backend, and it's going to run the app server. So this little highlight here is to point to the fact that also the Docker Compose.yml in here is using what's called volumes, which are essentially folders in your host computer, which are mapped to folders inside the containers when the containers are run. Because the important thing to note is that a Docker container is not a virtual machine. A Docker container is ephemeral, whereas a virtual machine is persistent, in the sense that a VM, when you close the VM down and open it up again, all the files that you had are going to be there. Whereas a Docker container, if you run it up and then you do some stuff to it, like you install WordPress, you complete this install here, you've finalized the database, you write a couple of blog posts, you install some plugins. If you then close down that container, that work that you've done setting up the database and setting up WordPress, that's going to be gone. So you're going to have to do it again every time. That's not very efficient. So the reason I'm picking this particular Docker Compose thing is that it worked really quickly out of the bat, and it had the volumes already set. So when the containers are running, or when the containers are not running, there's going to be a MySQL database in this folder, and there's going to be the install of the WordPress project inside this folder. So even if the containers aren't running, we can still look at the contents of the database, and we can still look at the contents of the web root folder of the app server. So that's why those volumes are absolutely ideal, because it saves us time doing it again. Once we've installed our plugin, it's going to persist across runs of the containers. So now let's install our target plugin. I happen to have randomly picked something because I just used the GitHub technique to find something using add shortcode as the search term. Found the events calendar shortcode, installed that by logging into the admin panel, clicking plugins, add new, selecting it from the store, and there is, once that's happened, we could look inside that WP app folder that I was talking about. This is the volume inside visible from inside the host computer, so you can see inside the WP content plugins folder that the plugin was added here. So now that we know that this folder is here, we can edit files in there and do all kinds of stuff. So maximizing the light. So this is what Sam T was saying about bringing things into a more white box approach. Bring more light. That means turning on as much debugging as possible. Your host machine, in your host machine, edit the wp-app/wp-config.php file. This is the config file for WordPress. In there, you're going to add wp_debug, wp_debug_log, and wp_debug_display. So you just add these 3 lines here and make it true, true, and true. And then you turn on as much debugging as possible. There is these 3. This link here is explaining what these options do. WP debug basically turns errors on. Debug log means create a log file inside the wp-app folder. I think it's in the wp-app/wp-content, and it'll create a file in there which logs all errors that are coming from WordPress or PHP into it. This WP debug display it'll turn it on so that it's visible in the HTML page. So that you've basically tackled it in all ends. Once you've seen the error in the web browser, you'll know that it'll also be persistently stored in this debug log file. So maximizing the light means turning on as many errors as you can. Usually, this would only be for developers, but we are bad people. We're bad people, so we want to know as much information as we can too. Right? So now let's trigger an error, because once you've once you've turned on WP debug log, it won't create that file until you actually trigger an error. So wp-content/debug.log, that file won't exist until you've triggered an error. So I installed the that plugin that I talked about, and I triggered an error. And the way I triggered the error is I went to the source code in this folder. I opened it in a text editor, I think Nano, don't at me, as people say. And I added this line of debugging. So when I was saying you need to learn how to add your own debugging code, because sometimes what you're looking at in the source doesn't quite make sense. So you just go, just tell me what the value of the variable is here at this point. So you can just add an echo line. But it is going into an HTML response page, so you're going to make sure that you have a break line before and after, so that it's like adding a new line. It just makes it easier to read your debug statements. So yeah, what we can see from the source code here is that they did have the add shortcode and they did have the add action. So that's how I knew to add my debugging code to the top line of load languages, because I knew that this would be the thing that's called whenever this shortcode is visible. So to trigger this error, in theory what I would need to do is either make sure this load languages thing is triggered, and I think that happens when the plugin is loaded rather than when a shortcode happens. So I've added this debug thing, and then that triggered an actual error whenever I clicked activate. So here I am, that's my debug line that I've echoed out with the break line and the new line after it. And because WP debug display was enabled, you get the error message in HTML, but you also now have it inside the log file, like I said. So you get the best of both worlds. When you trigger the error, you get the error visible to you, so you know that your payload or your exploit has done something. And then you also know what it is because you can go and look at the thing. So in this case, it's worried because I've put a print statement, and my own print statement in that part of the plugin was triggering an error, a PHP error, because the headers are already set. So yeah, that's fine. Setting yourself up for success. Well, I think we've got us. We've gone there. Go us. We've smashed all our goals. If you've got to this point and you're still awake, then well done you. It's only me that's had quavers. So we've set our 4 goals. We've set up our local WordPress server. We've installed a target plugin. We know how to access the WordPress log files, and we know how to make edits to the plugin to add additional making edits to the plugin code to add additional debugging that helps you zero in on a vulnerability. So actually, all you need to do is take those little tools and I guess kind of run with it. So that's the challenge. If you follow along with the video of this content, which is, you're watching it, so that's a weird line for me to write, to be released soon. You're viewing this from the future, and future people, please tell me that the economy is fine. You can go hunt for vulnerabilities within WordPress plugins using these tricks to aid you, and you can find if you find something, I'd love to know about it. So you can absolutely tweet me or DM me on Twitter. I'm at CornerPirate. I'm throwing down the gauntlet. What you should have at this point is the ability to debug a plugin. I can't teach you the ability to go and find the vulnerability, but you've possibly got enough to go and do a bit of research yourself and maybe find another XSS or something even more exciting, because who knows what a shortcode is going to do. Have fun with that. If you want to get your hands dirty, you're going to need to see these URLs. That they're kind of all the URLs to explain the things that we've gone through. Our disclosure policy, if you're interested in XSS, if you want to have a practice of how to find and exploit the various kinds of XSS, the Portswigger blog's pretty good. That guide to shortcodes, guide to getting Docker on Kali, guide to installing Docker Compose via pip, and a guide to WordPress debugging. How am I doing? 59 minutes. I'm going to stop right there. Thank you very much for having me. I think the real me might jump in and speak if you have any questions. Cheers. And if you want to follow us, follow me on at CornerPirate, and if you want to follow Pentest Limited at Pentest Ltd, it's a low tweet count, high value research feed, so go for it. Bye.